Okay, hello students. Let us see the STES problem. So STES stands for your simplified test. It is a simplified version of your DES for educational purposes. Here, simplified test they'll be using smaller rounds, and we know it is a block cipher where it can take the plain text. So here in simplified text, either it can take a plain text of 8-bit or 10-bit. So let us look into the problem. So today, in this given problem, we want to encrypt an 8-bit plain text. Okay, the plain text is 01101101. We have two keys, K1 and K2. This is given in the question. They have also given that the block size is 8 bits, key size is also 8 bits, and it is using two Feastel rounds. And they have given the permutation tables. Like they have given an IP table, IP inverse table, EP table, P4 table, and they will also be giving you the S boxes. So they have given you two S boxes. So likewise, they will be giving you the question. Okay. So let us start with the understanding of how the SRS works with the block diagram, and then we look at how I have solved it. So this is the structure or the workflow. So first, we are taking the plain text as I already explained. The plain text is of 8 bits. So the 8 bits input is passed through the IP table. IP means it is an initial permutation table where the output also will be 8 bits. So 8 bits will be splitting up into 4 bits. One is the left hand side and the right hand side. We'll take only the right hand side 4 bits, and this is passed through an expansion table. So this 4 bits will become 8 bits after this EP table. So this 8 bits will be XORed with the key. They have given the key, right? So the key consists of 8 bits. So this both will be XORed, and we'll be getting an output of 8 bits again. So that again we will be dividing it into 4 bits, 4 left hand side and 4 right hand side. So now with this inputs, we are going to look at the S0 and S1. That is nothing but the S boxes. So generally we know in S box and DES also we have seen that in order to read values from the S box, you have to know the row and column so that we are able to fetch the data. So this 4 bits that we are getting here, right? So the row, the first and the fourth bit position will denote the row, and the column will be denoted by this second and third column. Similarly here also. So this input will be looking at the S0 table. So this will be looking at the S1 table. So for the given question, let us say for example we are getting an output of 1111. Okay, so next this output will be again fed as the input to the P4 box. So there is a P4 table. So the output of the P4 also will be a 4 bit. Now this output will be XORed with the LS. We having this LS 4 bits, right? So that LS 4 bits we will take an XOR. That will be the output. We'll be getting an output of 4 bits. So that will be kept as the left hand side now. Okay. So that is called as your LS. So the right hand bits that we have got from the IP table, right? We'll be taking that as your right hand side, and then that becomes, then we do the swapping. So now this RS will become your LS, and now the LS will become your RS. With this as the input, okay, for the second round, again we have to proceed with the same step. So again it has to pass through the EP table. Again we will be doing the XOR addition with the K called K2. Again we'll be splitting into bits. Then we'll be looking at the S0, S1 table. Again we will be passing it via the P4 table. Again this LS bits that we are having here, right? So this will be again inputted here to get the output. And finally we have to pass it to the IP inverse table so that we get the ciphertext. So this is the workflow. Now let us get into the problem. So STES, for example, I have taken from the problem. It is 0, 110, 1101 is a plain text. So in the first round, what we have to do, we have to pass it to the IP table. So this plain text, you have to do the numbering like 1, 2, 3, 4, etc. So in this, the output of the IP table will be, we have to take the bit positions in the second position. So in the second position, what is the bit value? 1. Like sixth bit position, the value is 1. Third bit position, the value is 1. First bit position, the value is 0. So likewise 4, 8, 5, 7. So we have to convert, or we have to pass it via this table, and whatever we are getting, that is your output. Okay. So this, we are going to take the LS and right hand side. So LS we have seen, we will not touch. We'll be taking only the right hand side bits, and then we have to pass it to the expansion table. So right hand side we have to just the bit value is 0110. I'm just writing the bit positions 1, 2, 3, 4. So expansion table, how the bit positions are, it is 4123 2341. So what is the value of the 4? Fourth bit position is 0. First bit position is 0. First position is 0. Second position is 1. Third position is 1. So likewise 2, 3, 4, 1. This EP table they have given you. So just you have to put the EP table and substitute the values here. So once you have got the EP value, so this value should be XORed. This is the 8-bit. Now we have seen this 4-bit is converted to 8-bit. So that is basically the work of the expansion table. Now this 8-bit will be XORed with the key. So key they have given you 10100100. So this bit value will be XORed with the key. Okay, so the output will be, so these are the two values. So the output will be 1001 1000. So this you have to split it into left hand side and right hand side. So left hand side you have to read it as a row and column. So row will be 1 1, column will be 0 0. So 1 1 value will be 3. So likewise 0 0 value will be 0. Next, for this side, 10 is a row, 0 0 is a column. Okay, so we have to note down these values. Then what we have to do is we have to refer the S0 and S1 table. Okay, so I have shown this. So the S boxes, these are the rows, are 0 1 2 3, and likewise we have the columns. So for the first thing, row is 3, column is 0. So row is 3, column is 0. So the value will be 3. So 3 again we need to convert it into binary. So binary value will be 1 1. So likewise for the second side, second row, 0th column. So it is second row, 0th column. Again the value is 3. So we have to note down 3 and convert it into binary. So now we have to add, we will be writing both as a combined value. So 1 1 1 1. So this is the final value that we are getting here. Okay. So 1 1 4 ones. Okay. Now this we have to pass through the P4 table. So what is P4? P4 value is basically 2431. So since everything is 1, we'll be getting the output also as 4 ones. Okay. So this output only we'll be XORing with the left 4 bits of the IP table. So in IP we have initially found out value, no? So that is basically your 4 ones with the left side bits, 1110. If you XOR, we'll be getting 301. So after getting the value, we'll be swapping LS to RS and right hand side to left hand side. And now this becomes as the input for your EP table. Okay, so we will leave the left bits. We are going to take only the right hand side bits. So right hand side bits, 4 bits are there. It needs to be passed to the EP table to get the output as 8 bits. Okay, so the bit positions are, as I told you, it is 1 2 3 4. Okay, so we are passing it to 4 1 2 3 2 3 4 1. So fourth bit is only 1. So 4 alone will be writing 1, remaining all will be 0. So we will be getting the bit position like 1 0 0 0 0 0 1 0. Okay. So now what we have to do? We have to do the binary operation with the key called K2. So K2 value they have given. 0 1 0 0 0 0 1 1. So we do the XOR of this output with the K2. So we'll be getting some output. Okay, 1 1 0 0 0 0 0 1. So this again we have to divide it into left and right side. So left side it is 1 1 0 0. So this will be the row, this will be the column. So likewise this will be the row and this will be the column. So 1 0 means the row value will be 2, 1 0 again 2, 0 1 means it is 1, 0 0 it is 0. So for this left hand side, we have to refer the S0 table. For right hand side, we have to refer the S1 table. It's the same table. Okay, only one table they will give. You have to go and refer there. So 2210. So now let us look at the table. So 2 2. So row is 2, column is 2, the value is 1. Okay, so 1 means you can write it as 0 1. Next one is row 1, column 2. Sorry, some mistake. Okay, row 1, column 0. Okay, row 1, it is column 0. So the value is 2. So if you write it in binary, it will be 1 0. So now you have to write all this as a 4 bits. It is 0 1 1 0. Okay. So now after you write this, now the right hand side will become 1 0. So now the new bit we have found out. So this will then be passed through a P4 table. So P4 value is 2431. So if you write this bit position, the output will be 1010. So now this will be XORed with the left hand side bits. Okay, in the previously we have taken as an input, no? So if you are XORing with the left hand bits, so let us see what is the left hand side bits. So this one. So here we are having this, no? 0110. So it is 0110 will be XORed with this 1010. So if you do, we'll be getting the value as 1100. Okay. So this 1100 along with that right hand side bits. Okay. So now this will be passed through the IP inverse table. So IP inverse table, the bit positions are 41357 286. So if you're passing that value into this IP inverse table, now we'll be getting the value. So this is basically 01000110, which is the sucker text for your plain text. So this is how we have to do the sums for your S test. So this is the final value that we are getting. Is that clear? Any doubts? So try to follow the diagram and then you try to do this. Otherwise, we will be getting confusions here. Okay, so this LH, this left hand side will be 110. So right hand side is nothing but your 0001. This is nothing but your old RS we are taking here. Right hand side RS. This value only we are taking here. That only we are passing through the IP table. Okay. So I have given you another problem. Just you can practice this and I have given the solution. So you just this tables that we are showing, no, it will be maximum common for all the STS type problems. So only thing is the plain text and key might vary. So sometimes they might give you a plain text of 10 bit. So in case if they are giving a plain text of 10 bit, sometimes they might give you an 8-bit key. They will also give you P8, P10 tables also. Okay, so there is another type of problem also that you need to practice. Now, coming to the problem 2, so they have given 2 keys. Other tables will be the same, like IPA, IP inverse, P4 table, S boxes will be the same. Okay. So for this, I have got some pictorial representation of the values. So this is a overall compressed view of how they are solving. Okay. So it's the same step that we have seen. So plain text will be passed through an IP, then expansion table, then with a key called K1. We have to look at the S0 and S1 table. So S0 and S1 table they have given here. After that, it will be passed via a P4 table. Then you take only the you take the bits LS and right hand side, and then you do the swapping. So after doing the swapping, then again we'll be taking the input, pass it through the expansion table, do the K2, then pass it through the S0 and S1, find out the value, then pass it through the P4 table. Again you do the swapping. The output that we are taking will become your right answer, and right answer will be the left answer. So you just do the swapping, and finally you have to do the IP inverse to get the ciphertext. Okay, so you can have this and you can just try. You have to work it out. Only if you work it out, you will be able to solve the problem. So just give it a try. And in case still if you're having any doubts, we'll see. Thank you.